Mic check. Hi, everyone.
Hello.
Hello. Can we all hear me?
Okay.
Hello.
Good afternoon.
Good afternoon.
Okay, can you hear me now?
Yeah, I can hear you, okay.
Awesome. Can we all? Okay. Then. All right. So thanks for joining us, Mercy. Now, I think there's almost all of us here, so we can start. I'll just do a very brief introduction and leave the rest for you to do. So we are so excited to have you here. We don't take this for granted. So everyone, Mercy is currently a data scientist at One Finance. That's the company under which Carbon or Pay Later, as you may know it, is. She studied civil engineering at Covenant University, and now she works at One Finance. Mercy, we are so glad to have you here. Thanks for joining us here. So I'm going to leave the rest over to you now, so you can do the main introduction, so I don't speak too much.
Hi, everyone. So I hope you can hear me. Hi. So I'm Mercy. As she said already, I work at One Finance as a data scientist. Before school, I studied civil engineering. Well, she has already said that part, but basically, some people ask why data science as after studying civil engineering, but my experience on the construction site wasn't so exciting. Like I felt quite bored and underutilized during my while I was in school. So after I came back to school, yeah, let me just turn on my video for a while so everyone can see me. So hi, it's me. So after my internships, and then I went back for my final year, just like thoughts of being miserable after school, working on construction sites just made me find another line of work to pursue. So before I finished, I took a couple of introductory courses just to see if data science was something I would give my all to when I graduated. So when I finished school, I immediately started taking more courses online. So most of what I learned was from Data Camp, Coursera, and some other random places, blogs, listening to people, attending meetups, just a bunch of things put together, yeah, participating in competitions too. So this was in 2018, from August 2018, and by February, One Finance had, by then they had a remote internship for people. So they put out a call and they asked for people who are interested to learn about data science to come in and learn with them. So we're the first sets to go through the RISE data science remote internship. So it was for about 12 weeks or so. 8 weeks of like hands-on content, or was it 9 weeks? And then the rest was a project where we were given live data, that's the actual customer data. That was like the best part of RISE for me. Like we got to work with actual data that they had gotten from people, not all the story data sets that we play with when we initially start out. So it was quite interesting. And after the internship, a couple of people were selected for interviews, like the top performers during the internship, and I was lucky enough to be amongst those people. I had my interview, it went pretty well, and by May of 2019, I was already working as a data scientist. This is someone who started learning about data science at the end of August the previous year. So I would say my journey has been smoother than most people because I've had like an incredible support system. So aside not having to deal with a lot of issues that people in tech or basically just people in Nigeria deal with, like things like electricity. So I have like stable electricity where I'm at. So I have had that privilege to work longer hours as to maximize my day better than most people would. So during those first couple of months, like I was pushing like upwards of 8 hours steadily, 6 days a week. So say I was working on stuff for like in a week, I could put in as much as 40, 50, 60 hours just learning stuff online just because I could. So yeah, and then I was learning from a hub here in Kaduna. Yeah, I'm based in Kaduna, so I work remotely for One Finance. I work from my room. So because I I used to go to a hub back then. The hub is called Collab. You can check them out on Twitter. Amazing people. We have like this small community of people all learning similar stuff. So I had like my data science crew. So it wasn't really hard, so to say. Like data science isn't easy stuff, but like when you have people who are above you and have already gone through these things, it won't be as hard because you have guidance. So a lot of the initial confusion is about what to learn, what to focus on, what is important, what is irrelevant, what is relevant. So as a beginner, it's hard for you to filter all of these things, like because you don't know what you need to, like the most important things you need to learn. So that support system, that community was really helpful to push my progress faster than I've seen others progress in this. And to fast forward back to me, I started working with One Finance, and it has been a roller coaster since then. Like you should just do the math. That's someone who just started learning data science, say 6 or 7 months before they got their first job. You can't expect the person to know so much, but like they believe that I am smart, I'll learn on a job, and I'll definitely figure it out. So that's basically a summary of my work experience so far. It has been a lot of figuring stuff out on the spot. Like there are so many things that I had just done for the first time, even during the Arise internship. So it wasn't like I was ready at the pro level or anything like that. No, no, no. I was just super curious, and I was like, I had time. I had. I feel light is very important. I had electricity. I had constant internet. So all of these things were like very helpful to just keep in that pace going and continuously improving on myself. So that's basically a summary of me and how I got to be in data science. Everything else there has just been working for working at the company and building stuff like internal tools. I've not done as much personal projects as I have imagined I'll do, like looking back towards last year. But I'm glad that I've learned a lot more than where I started last year. So I'll just dive in to the topic I'll be covering today. And then if anyone has any questions, you can ask the questions in the Zoom group chat. So I'll check that intervals to see if there are any questions for me. So can we see my screen? You can just raise up your hand if you can see my screen.
Yes, we
All
can.
right, cool. Okay. So I'll be covering feature engineering, basically how to transform data, like what goes into making a feature better, changing the format of a feature, just cleaning data, things like that. So I would give a summary. It won't be too in-depth. Like I have examples here we would look through, but it's going to be interactive, yeah. So I'm going to work with a few data sets. I'll share this notebook with you, so you'd be able to run it at your spare time. And I should have shared it now so you can follow along actually. Okay. Let me get the link to this and share it over there just in case you want to. Yeah, so you'll be able to view. So that's linked to the notebook. You have your access to the notebook. So the first thing I would cover is something we do a lot. I didn't even know this is what it was called, but it's called the split, apply, combine strategy. Something that Pandas is really good at. That's their Pandas functions that handle this really well. So basically the concept is just about, say you have a huge data set and it's more informative if you look at groups in the data and not looking at everything as a chunk. Like you get more information if you break it down into smaller groups, and then you can give, say, summary statistics about a group. You'd have richer insights if you're working with smaller groups than, say, if you're checking, say, the mean now of every client in the data sets, like their mean age, or I'm just giving a dummy example, but let's say we have two columns. One has to do with classes. So say they're in primary 1, they're in primary 2, they're in primary 3. Then there's another one that has to do with their ages, so how those students are. So you could decide to do a general mean of everybody, and then you have just one figure. But this one figure would not be so informative, because imagine you bunching up people in nursery 1 and people in SS3, and you're finding their mean. Like once you give someone the result of this value, you'd have, say, a funny mean like maybe 15 for even babies and comparing them to people in SS3. But then if you do a subgrouping and you have a mean for each of these classes, so say you have a mean for people in primary 1 now, you can see that in primary 1, their mean age is usually 7 years old or something like that. So that makes a lot more sense than giving the mean of general group as 15. But yeah, so the split, apply, combine strategy has to do with splitting the data into groups based on some criteria. So you get to decide what that criteria is, if you're working independently, or the company's goals or objectives, or that business problem you're trying to solve would get to define that criteria for you. And then the apply part is just you applying a function to each of the groups. And then finally, the combine is when you have it, say, in a data frame or in a format that is easy to view, basically. So we're going to work with one of the most popular data sets. I wanted to work with stuff that is easily accessible. So there's the Iris data set is already loaded inside the Seaborn package. So I'm guessing you guys have either heard of the Seaborn package or have used it before. So it's kind of like, I like to think of it as an extension of the Matplotlib visualization library, but it's a lot more pretty. So from Seaborn, would import the Iris data sets and work with just a subset of data. So we're just interested in, about 15 rows from each of the species. So this iris data set gives us, is a data set about some flowers. So it has columns for the sepal length, sepal width, petal length, and then the petal width. So we're working with just a subset of this data to highlight or show the examples of how you can use the split apply combine strategy to data. So the splitting part is usually done with a group by. Like in this function here, we have two things in one here. So we're splitting and then we're applying a function to the split. So we're doing a group by on the species and then we're finding the sum of those species. So now just by running that cell, we can see that this over here gets transformed and condensed into this form. And this cell, I want to show you something. I won't talk about this so much right now, but when we come back, just put it in memory that the index for a group by done on just one column is just a regular index. Like it's called, like this is how the index looks like when the group by was done on one column. So what just happened was that the group by arranged the data sets, we're doing a group by based on species. So it's stacked, like it arranged them based on the species, and then for every column, it does a sum. So it sums the values are found underneath a column for each species. So for Certosa, it adds these 5 values. Let me see. I can do this. So it adds these 5 values. And then at the end of the day, we have 24.3 as a sum for that column. And okay. And that's like a simple example for where the apply starts from. But a bunch of things you can do during the apply step include, you can do an aggregation. So you could compute a summary statistic for each group. So things like the sum, the means, you can find the counts of how many items fall under that group. So that's the first thing we can do. We can do an aggregation. We could also do a transformation. So a transformation is you changing how the data looks like. So you can perform, say, a group specific computation and return an object based on that computation. So it could be something like standardization now. So you have data that is very noisy, but you want it to be in a format that your model is most likely going to benefit from. So standardizing data has us having, I think standard deviation is going to be 1, and then mean will be 0, something like that. That's like the, what's the word? What goes into standardization. And then you can also fill in the missing values based on a specific condition. So say we're working with ages now, and there's some values in the ages column that are null, but then intuitively, you know that all these people are in the same class, so they'll most likely have a very similar age. So instead of filling or leaving that field as null, you could fill it with the mean of their classmates. So you'd have the mean age replacing all the nulls. And then for filtration, say your filtration involves, well, like the term says, filtration, we're just going to apply a condition and select just a subset of the items we're interested in. So say we're interested in just people that, we're interested in finding the means for only those that are below 18. So anyone that is above 18, we are not interested in you. So you can filter first before you do your computation. And then you can either discard data that belongs to the groups that have few members, or you can filter out data to based on the group sum or the group mean. So there's one thing I would like for us to avoid. So I did like a little experiment just to show you that when you're using a group by, I'm going to highlight. Okay. For this cell I'm currently working from, the code over here is first the data frame, then the group by, and then you select the column you want to do the group by at before you do the distance aggregation. So for something like this now, if you first do the group by, the aggregation before selecting the column, your processing time ends up being longer. So when you're starting out, you'd most likely not worry about how long it takes for functions to run. But when you start working on projects or working, say, for a company, they're very concerned with how fast processes take to run. So we're always trying to cut down on execution time. So you have to write efficient code basically that takes a shorter time to run. So the difference, these two cells, the one I'm running now and the one I ran previously, have the exact same outputs, but the first one takes a lot longer to run. So the first one took 1.84 I think milliseconds, I think it's milli, and then this took 758 microseconds. So you can see that it's like way faster, and the only difference between these two things is that for the second case, you first selected the column you're interested in, that's after the group by, before doing the aggregation. But in this case here, you first did an aggregation, that's the sum, before you then selected the column that you're interested in, which shouldn't be the case. Like, to do your computations, you should do all your selections first before you run the aggregation. Like, you would end up having a faster execution time. So I was, this is the same as the cell above. To display this output previously was what's it called? Was a series, but this is a data frame. So to make it into a data frame, all you need to do is just to add another square brace to the column you're selecting, and boom, you have a data frame. So in case you prefer the prettier format, that's a data frame, just remember to add the square brace. But automatically, if you're selecting two columns, you end up with a data frame. So now I'm going to talk about what happens when you group by multiple columns. So when you do a group by on multiple columns, it's literally just does a group by multiple columns. So we're grouping by species and we're grouping by the petal width. So we have values. The computation that is being done is a sum. So at the end of the day, you have sums for each species, and for each petal width value, you would get a sum. So for Setosa now, everything that is Setosa and is also 0.2, all their petal lengths will be added, and that's how we ended up with 24. Same for the others too. So for the others that have multiple petal widths, the same thing too happens across board. So they get added individually. So we're not just concerned with things that have the same species, we're also concerned with things that fall under the same petal width, and that's how the computation happens. So remember earlier when I said that you should take note of the index for a group by done on a single column. So this group by here, the type is, it's a multi-index. So a helpful tip about something like when working with multi-indexes, there's this cool thing you can do when you're selecting or subsetting from a data frame. So if the index type is a multi-index, you can leverage on that, and then you can easily select or have a subset of your data set based on that value. So over here, we're interested in only the Virginica species type and then the level of the species. So just by putting this, it returns all the values or all the flowers that fall under this Virginica species. So it returns all their values. So we basically subsetted, or we have a subset of the data based on the index. So there are other ways of finding subsets, but this is also one way if you have a multi-index type of index for that data frame. And another thing you could do with that is, say you're interested in, now you can go the extra mile and also use it as, like how you do .ilog. So you can use the location of a particular row, and the petal width in this one is 1.9. So if you use 1.9 as the value that you're interested in, and then the level being petal width, it will return the other columns for a petal width that is 1.9. So it will return the values for the sepal length, the sepal width, and the petal length for those values that are 1.9. This is will soon be done with this section. If you don't like this multi-index format, as you'd rather have everything as singular rows, you can do something we call flattening an index. So you can flatten the index with the reset index command. So if you run reset index on a multi-indexed data frame, you end up with everything flattened out. So everything is now an individual row. But I left this for last. But if you didn't want the multi-index from the start, all you just had to do was use as index equals to false, and boom, it returns it as a flattened out data frame. There's also a function that you can use to run the apply. So if you run .aggregate, you can put in a function into the aggregate function, and then it does the computations for you. So you can find things like the mean, the max, the median. There are a lot more things you can find. There are a lot more functions you can apply. This was me being curious to how the describe will look for this multi-column index data frame. So for the sepal lengths, I think I'll just skip this section because I might even take it out of the notebook. But moving on, I was just showing some examples of other abbreviations you can run. So this was the mean and how describing it would look. yeah, common aggregations you can run in the apply function. So you can do means, sums, sizes, as computing the group size. So this is mostly explanatory, so I won't really dwell on this. And yeah, you can also run multiple aggregations on the individual columns. So you'd end up having as many aggregations as you want to show. So when you do a describe, you get a generic count, mean, standard deviation, and all of these things, but you can decide to do just the ones that you're most interested in. And there's also something called a named aggregation. So a named aggregation gives you a bit more flexibility in how you do your aggregations. So you'd have, for this first one over here, we're finding the minimum, like what is the minimum of sepal lengths for the species, what is the max of sepal width for the species. So for this one now, you can be a lot more specific and you can work with so for each column, you can decide what aggregation you're going to apply to it. So instead of having them all displayed like this, you can choose just the ones you're interested in. So it's you further filtering and your result at the end of the day. And yes, you can also use Lambda functions. So Lambda functions are this tiny, easy to write functions that are very powerful. So you can also use Lambda functions for this to transform your values into other, so you can apply formulas and then you'd have something. So say there's a formula to calculate the weight of a flower based on the measurements of its sepal and petal widths. You can apply that right now in a Lambda function, and then you'd have a new column that could tell you the weight of that flower just based on those dimensions. So yeah, that's it on aggregations. So for the filtration part I mentioned, you can filter based on a specific condition. So over here we have I found the sum of, I did a group by petal width first, and then after the group by petal width, I did a sum aggregation on the sepal lengths. This is not the main thing. I just want to show you how a filter works in here. So the filter over here is, the filter happens, or the filtering happens here. So we're filtering for values where the sum of sepal length should be greater than 19. And this is sepal length. You can clearly see over here that there are only two values where their sum is greater than 19. That's this first group here where their petal widths are 0.2, and this second group where their petal widths are 1.5. So if you check over here, the only values that get returned are the ones, like one way to know what just happened is that all the petal width values here are 0.2 and 1.5. Same values where their means were greater than 19. The rest of them were less than 19. So over here, the sepal lengths that were returned to us finally were lengths that fell into a subgroup that had their means greater than 19. So yeah, this is what happened. It's looked at it as different groups, and then it's selected just values that their sums were greater than 19. So that was that's basically what goes, or that's most of what goes into the split apply combine strategy. And there's a few more things you can do with it. So depending on your use case or the problem you're trying to solve, you can apply that over there. So I'll take like a short break. If you have a question, you can ask now. If there's anything you need me to go back to or just to show again. So you can type that now while I talk about data cleaning. So one thing people don't, or some people do not think is as serious as others say is data cleaning. So you'd spend a lot of your time cleaning data because data is usually messy. Like you can try so hard to have your data in a format that will just be perfect for the use case, but somehow something always messes it up. There's this quote by IBM that says that 80% of a data scientist's valuable time is spent simply finding, cleaning, and organizing data. And then you're spending the other 20% actually performing the analysis. So the thing about why data is never clean, like some of the reasons, it could be just human error. So maybe the person forgot to fill in the field, and things like this are also related to bad design. So if you want a field to be compulsory, that's from the design perspective of it now, the devs should have made it a compulsory field. So we have cases where fields are important, but they are not made compulsory. So at the end of the day, that field is just null. And then it could also happen during the ETL process. That's when you're extracting and transferring data from one source to another. So during that transfer, some data too could be lost and something could just happen. It could also be a programming error. So maybe the person entered that field in, but that field doesn't get saved. And then one that is probably common over here, that's a user will choose not to answer a question just because of their belief. So you might ask someone if they try say, I don't know if it's a good example, but if they take alcohol and then because of maybe it being frowned upon in their churches now, something like that, they could decide to tell you no, even though recreationally or occasionally they take alcohol sometimes, but like just because of that thoughts in their head, they might decide not to answer that correctly. And then there's also the case of the user intentionally filling fields wrong. So this is something that has been suspected to have happened with the census data that was collected a couple of years ago. People believe that a lot of people falsified their results. So questions that were deemed or people suspected will cause them to get a bigger chunk of the national cake. Things like how many children you have or things like that. Some people feel others might have added a lot more values than is actually true. So these are like a few of the reasons for why data can end up being unclean. So for some values, you end up seeing that everybody's age is like within the range of 18 to 60 or 70. And then you just check that column and you're seeing someone that says that they're 200 years old and you're wondering, how are you 200 years old? Like, so those are kinds of things that you see in data, like really, there are things that wouldn't make sense to you and you'd be wondering why this is here, like it shouldn't be there. So for the different types of reasons for why data is missing, there are actually different ways to handle missing data based on the reason why. So first thing is to understand why the data was missing in the first place. I'll try to be faster because it looks like we're running out of time. But there's a link over here to tell you more about reasons for why data went missing and how you can handle those specific cases. For the more practical part of this, we're using data from a site called Real Python. So the first data set is a CSV containing information about books from the British Library. The second is I didn't use that one. But the third one is a CSV file summarizing participation of all countries in the Summer and Winter Olympics. So this is an overview of the data sets. So you can already see we have missing fields in the addition statements. In date of publication column, this date value is definitely, like, there's no date like this. It should just be one value. Books can be published in 2 different dates, except if it was a republished version. And then there are a lot of missing fields over here. And so for columns that have lots of missing fields, most times we just drop those columns because they aren't so informative and you might not miss out if you drop out those columns. So I checked the columns that had the most missing values. So over here, doing the data frame.info tells us that this columns over here, corporate author, corporate contributions, you can see that they have just 1 or 0 values. This one's addition statement, so has very few values. So I dropped all of these columns and we're left with this data set over here. So you can, this is one way to do this, using the column you're going to drop, as this here to drop, which is a list of the columns I want us to drop, and then adding the axis. The axis equals to 1 stands for you dropping columns. If you had put 0, you'd be dropping rows. So the second alternative is you can bypass doing this axis if it's kind of confusing for you to remember which is axis and which is the, like which axis value is for column and which is for row. You can just go straight ahead and use columns equals to drop. That's your explicitly telling you to drop just the columns. And this in place just tells us to replace or to do the drop in place. So we're not creating a new data frame, we're working with this data frame that we have over here. And then a more programmatic way to do it is that you can decide to use a specific criteria. So you want to drop any column that has more than 30% of its value missing. So instead of like taking out your calculator to calculate 30% of each column, you could just do, you could first find the sum for the distance, the missing, like how many missing values are missing from each column. So that's what we did here. So we have this columns have the highest amount of missing values and these ones are all complete. So doing a box dot shape, this gives us the shape of the data frame. So we can see that there are 8,287 rows and then 15 columns. So initially I said we want to drop 30% of, like any column that has more than 30% of the values missing, we're going to drop it. So you can see that the data frame has 8,287 rows. So this over here just finds what 30% of that value is. So doing indexing the shape, indexing the shape of the data frame by 0 gives you how many rows are in that data frame. So multiplying by 0.3 is the same thing as 30%. So we can see that 30% of this is 2486.1. And then I checked for how many columns meet this criteria with this here. So how many columns, like six columns have their missing values greater than 30% of the total number of rows that are in that data frame. So we're just going to extend the manual method we used and use this computations to do the drop. So if you use we did, why I can do columns to drop the index 0 to 6 is because I ordered my variable over here. I ordered it by the highest number of drops, as those that have the most drops will come first before those that have the least drops. So I can easily use an index, seeing as I know how many columns have more than 30% of values missing. So I can use an index of 0 to 6 and drop these guys without having to find out the names of these columns and typing them in. So after you do the drop, you'd end up with 6 less columns. So you have 9 columns at the end of the day, and all of them have more than, like all of them have less than 30% of their values missing. So that's like the first thing you can do. You can just drop columns that have too many missing values. Another thing to do to clean your data is you can change the index of the data frame. So for the index, if the index your data frame came in earlier isn't something you want to work with, but there's also another unique identifier in the data frame, you can use that unique identifier as an index, and then yeah, you work with that instead. So the initial index that was added to the data frame by default is a range index. It's just a random, like it's basically just a count of 0 to the last row in the data frame. But if we want it to be more meaningful, we can decide to use a column in our data frame that has that is unique. So we have the identifier column that can serve as an index. So I just used the booksdf.setIndex function, and that became our new index. So if you check for more information about this index, you'd see that it's an int64 index, and the index has a name. Unlike before that, the index did not have a name. Like it was just start, stop, and that was just it. And then why it's good to have a unique index that is informative is you can also, it will work with the range index too though, but like you'll be able to use the loc function, and then if you do the loc on this, you can use the identifier. So say your identifier was a phone number. Now you can use phone numbers to get a subset or index the data frame. So if I put in my phone number now, it will return all the information about me. So that's why it's good to have this informative index rather than just a count from 1 to the end of the rows in the data frame. Yeah, it was just, this is like me trying to show you difference between using .loc and .iloc. So the loc uses the name of the index. So if for every value over here, it will show you the exact values are stored in that part of the data frame. So for this number, these are the fields that are underneath the columns in there. While .iloc uses the index. So the index Python is 0 index based, so it starts from 0. So this is index of 0. This is 1, 2, 3, 4. So it's just going back to the range index we just avoided. One other thing you can do is to clean up. So if you check the data, you can find out that there are things that are not supposed to be there. Like for this row over here now, this is supposed to be for the date of publication, but we now have a weird value in here, and this shouldn't be. So random, like data cleaning is more of an art, so to say. Like there are things that you'd have to just think through and figure out how to handle. And if that's how it was supposed to be, or if it was just a mistake. Yeah, so you'd have to think things through before you decide to apply a specific cleaning method to a specific column or set of values. So for this one now, we can see that everything else is in proper year formats, but these ones have weird formats attached to them. So this could be difficult to clean, especially if especially if the formats are different. Like you can see that there's no this and this, they are not in the exact same way. Like they're different in a way. This looks more like an age range 38 to 54, and then this looks like the person was doing 1860 to 1863, but just forgot to add the first 18 parts. But you can use regex to help you clean things like this. So it might look like there is no pattern, but there is a pattern for that case. So there's this joke about regex being hard to understand and it just not making sense. Yeah, looking at regex statements, they don't make that much sense if you've not used them lots of times. So it just looks like a cat was just on your keyboard, or you just randomly typed rubbish. That's how reject statements look like. Like this is the one we'll be using over here. This is what will help us clean that row. Like looking at this, you wouldn't guess that this is what will help us clean that row. But what this means is that the D here stands for digits. And then the 4 is that we're just interested in the first 4 digits. So this over here is the equivalent of starts with, and that's basically what this reject statement means. So if your starts now with regex is very important for cleaning data. Like you'd use it in SQL, you'd use it in Python. You can, there's a site where you can tinker around with regex statements to figure out how to extract the exact pattern you're interested in. So the links are in here. You can open them and check out. You can inspect this expression over here to see how it works. And then you can also read, there's a Python regex documentation page that is very robust. So doing this, we're extracting just values that fall under this criteria. So it should start with, it should be at the beginning of the string, and it should be a digit, and we're just interested in the first 4 digits, and that's what we have at the end of the day. So you can see all of this have now been cleaned. What was I doing here? Okay, here I was doing a type conversion. So you can convert from one type to another. There are times when you would read in a CSV file and you see that a field that was supposed to be numeric or supposed to be strings are not in appropriate format. So you'd have to convert those data types to the right ones. And then there's there's like a lot of methods that you can do on strings. So you can use the .str to access those methods. So things like splitting, replacing, capitalize, upper, lower, just string manipulations. We're going to use that now to clean the place of publication field. So if you look at the place of publication field, you can see that these values are not consistent with the other ones. They have other things in front of them that we're not interested in. So we just want it to be a proper location. So for this particular one, we noticed that it was books that were published in London or Oxford that had this anomaly attached to them. So you can use str.contains to find every field that might be affected. So we want to just select, fields. Like I said, it has to do with fields that have either London or Oxford or this one over here, the Newcastle one too wasn't in a proper format here. So this and this. So this is why data cleaning takes up to 80% of the time. Like, there's no manual to this thing and you never really know what to expect. So you start digging into the data, you just see really funny things inside data. So it can take a really long time you're doing it by yourself. It could take months to clean a really messy data set, or if you're lucky and it's not so messy, it could just take you a couple of days or a couple of hours, depending on what you're dealing with. So over here, we're checking for all the values that contain either London, Oxford, or this thing, or this Newcastle upon Tyne, and then we are going to replace those values. Like, we want to have it be just London. So that's what that over there does. And I'm going to skip this. It's supposed to take it out. But yeah, so for renaming columns, you could read in your CSV file by default, and then you'd see that the column names are not tidy. So you'd need to, there are specific fields you can pass into the read_CSV function to avoid cases like this. So for this one now, if you skip the first row, the first row now can now be used as the column header. That's for this specific case. And then you can further clean this by using a dictionary. So you have the name from the column that was just read, and then you can have the new name you want to give it. So all you just do is to rename all the columns of the data frame. So the .rename function takes in the dictionary values that you're interested in. And at the end of the day, you have a clean data frame. So this is the last segment, data discretization. So this is also known as quantization of binning. It's basically a way to convert continuous features into discrete features. So continuous features are features that keep, should I say, adding up. So there are things like age, weight, like these things are not, they don't have a particular value because they always change with time. So that's what a continuous feature is, but we want to change it more into a discrete value. So discrete values are more, should I say, finite, like, or sorry, they're more constant or stable. So things like, let's see, I would use the, what should I use for discrete features? When I think of an example that perfectly defines these discrete features, I'll mention that. So for this, there are several ways you can discretize data, but I just focused on the two easier ones, which is binarizing and then binning. So binarizing, like the term binary, it's just turning a continuous variable or continuous values into booleans, that's 0 and 1. So you want to turn that entire, so we're working with ages in here. We have an array of ages. So we have 6, 12, 20, 36, and 65. And you're interested in turning it, like you want these values to be either 1 or 0. So if it meets a specific condition, but in this case, it's called a threshold. So if I'm using scikit-learn binarizer to do this. So the binarizer takes one value, which is the threshold, and anything that is less than this threshold gets stored as a 0, and anything that's higher than this threshold gets stored as a 1. So 6 and 12, after you call the binarizer and then you call fit transform on it, this fit transform is something that you do a lot with scikit-learn, with their preprocessing functions. So anything that is less than 18 gets stored as a 1. So 6 and 12 have now been converted to 1s. So this is something you might decide to add if your data is just too noisy and you don't really care about specific values. You just want to give something a true and false value. So is it present or is it absent? That's literally all you're concerned with. So these are the kinds of things that can help your model understand inputs better and then give you better outputs at the end of the day. And then the second thing you could do is binning. So binning is you placing things into buckets. So for those ages now, we've tried to set out 4 bins basically, because it starts from anything that is less than 20 gets put in the first bin. Anything that is between 20 and 30 gets put in the second bin. Anything that is between 30 and 64 goes into the third bin, and then anything that is greater than 64 goes into the fourth bin. So yeah, that's basically how binning works. So for guys that are between like people that are 6-year-old and 12-year-old, and yeah, those guys are in the first bin, which is 0, and then those that are in the person who is 20-year-old or 20 years old is in the second bin, which is 1. So the same applies to the other 2, and yeah, that's like this was just a soft introduction to things that go into feature engineering. Because I heard that this content was just covered in the class this week, and I didn't want to go too in depth, and then a lot more people are lost. So this is basically why I prepared for the class, but you can ask me any questions if you have any questions now. Apply map function. Okay, so let me see if there's another question. So I think did I use the apply map here? I don't think so, but where is, okay. So the apply map function, like how it works is that you can, give me a moment, yeah. You can build a function. So this over here was something that was built for this specific case. So the text files in here are in this weird format. So you have the states, you have the university name, and then you have this something in an array, and then basically in that format. So what this cleanup function does is that it's for every row in this text file, it's checks through the values that are inside that row. So if there is a left brace here in the item, what gets returned is it's going to find, like, it's looking for text basically. So it's looking for this first part, the -1, it's looking for the stuff that is by the left, that's for, sorry, for state, Alabama, it's going to search for Alabama, and then for the region name, it's going to search for the name of the state itself, and then it creates those columns. So the apply map function works, and like you use it to build custom functions for specific cases, and then you apply it to the data frame that you're working from. So I have a feeling I didn't answer this properly, because apply map, okay, let me start from the scratch. So the text files that we're working with is the universities, towns, text file. Let me just open, where is it? Let me see the original format of the text file. So this is the original format of the text file. There in rows we have, okay, and then read it in line by line using the read lines function in here. And after reading it in, use and enumerate states, these states, okay. So we extend pairs, downs df, then build a data frame with 2 columns. But in those 2 columns, we still had the data in this format. Okay, so what happened here was that in the for loop was that the data in the states, we used the filter function. So anything that had edits in it, like, got filtered into the states variable. So that's what gets built as the states column. And then you'd use the cleanup to search through these columns and assign them to either states or the region name columns. So that's like all I have for today. Are there any other questions? Is there something I should explain better? You could unmute yourself and ask if you don't want to type. Okay, Justin, I can stop talking now.
Hello. Hi, everyone. Do you have a question? I can see that you're trying to type.
Yeah, I'm trying to type.
Okay, so you can just unmute your mic and ask, or is it something that you have to get your text in as well?
Okay, I can. Please, I just want you to the best way to deal with missing values. Like, how do you work that? Because I've heard you go forward, you feel backward, you can either try the mean or the median, but your experience, what do you think is the best way to deal with missing values or fail missing values?
I'm finding it really hard to hear you, but I know you've mentioned missing values. What about missing values?
I said the best way to deal with missing values in your experience. What do you think is the best way to deal with missing values? Because
Yeah, so like I mentioned in passing, there's no singular way. Like at best, you can have a set of things that you usually do to missing value. So first thing you have to find out or try to find out why these values are not there in the first place. That's what is going to guide whatever you do to either replace them or drop those columns if there are too many, or just straight out do nothing about it. So if you're going to fill in the missing values with a specific value, and then at the end of the day, it's going to skew your data set or something like that, it's better if you just let it be and not to add that skew yourself. But if it's something that you're sure, like I said, for ages now, you're working with university students and there's some missing values, you know that the average age of a university student is say maybe 20 or 21 or something like that. So you'd know that you can confidently fill it in with the mean. But if it's something that's human, like your intuition, like it doesn't, you can't find a way to fill it in, then you could leave it in. There's something interesting that I remember someone doing. So he built a model to predict the missing values for what he was trying to predict. So he had data and he had a column that had missing values, but that was not his that's not his target. That column that had missing values was not Y. So he built a model that predicts the column that had missing values. And then after he predicted for the missing values, he then used that column to make his final prediction for what he was interested in. So you could decide to do something like that and just see what you get. I have not done that aside that class that I was in. So yeah, like there's no one true way, like there's no first the data, like for strings, there are different things you could do. For categoricals, there are different things you could do. So it's all just testing and seeing what might work best. Like no one really knows, like apart from those who have so many years of experience, but like it's mostly just a trial and error method for me to handle missing values. Like I try and then see what changes after I have filled this in with this value, like how has this impacted my results. So it's quite iterative sometimes. Just saw a question here about, can R be used to do the same feature engineering? Yes, R can be used to do everything. Like for data science, anything that you can do with Python, you can do with R. Some people even say even better, like you can do even better with R. That's debatable anyways. But for how effective is it, R is a very powerful language as well. It's just not like when you start going into machine learning or things like that, Python libraries are just friendlier to do stuff, and they're like a lot more Python libraries for different things than there are libraries. So things like TensorFlow now, I don't know if you can use R, or I doubt you can use R and work with TensorFlow. You'd have to use Python. So it just feels like, yes, you can have R in your belt, but Python is equally or even more important to know, especially if you're not just going to stick to either research work or just strictly sticking to data analysis. For data analysis, you'd be able to use R all the way, but when it comes to the science part of it and building stuff, Python is a lot more flexible for that. Binning, so let's go back to binning now. So binning is pretty straightforward. I'll just add, I can reduce the bin size, so you'd see 36, or add another, just to make it a lot more separated. 36. I want to add like bins, just, and then probably move this forward. So okay. Just wanted to add an extra bin. I don't know if that will help you. 20, 25, 30, 35, 40, 45, 50, 55, 60, and then 65. So now we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We end up having 11 bins. So for anything that falls in between 0 to 20, it gets categorized, or it's going to get represented as the index of the first bin. So 6 and 12 are between 0 and 20. So that's why they're now, those values are going to get converted to the index of the first bin, which is 0. And then for values between 20 to 25, we have just one of those, which is 20. It gets converted to a 1. For these other bins, 25 to 30, 30 to 35, we don't have anything that falls on that. Those are bins 2 and 3, so we skip to the next bin, which is 4, between 35 to 40. So we have one value that falls between 35 to 40. So anything that, okay, 2, anything that falls between 35 to 40 now gets represented as a 4. So this is like an easy way to make categorical features using binning. So you can just use the bins and convert the values you have as categorical. So the same applies to the other ones too. We have one value that is 42. It falls under the 40 to 45 bin, and the index for this bin is 5. And we do not have any values that fall under 45 to 50, but we have, or 50 to 55. Yeah, it stops at, but then for 55 to 60, we have one thing, that's 55 itself. So how it works is that it starts from, so it's actually from 0 to 19, not 0 to 20. So it cuts off from, so it's anything that is less than 20 and anything that is greater than 0. So it's 0, from 0 to anything less than 20, and then from 20 to anything less than 25. So at the end of the day, the last bin ends up being 10. So that's about using a binarizer. Then how do we deal with outliers in a data set? In a general case, especially when they have tendency to affect the skewness of our data. Okay, so outliers are tricky to deal with. So for outliers, is an outlier can be treated in a similar way to missing data. So you try to understand why this value is sticking out. Is it that when was it human error that caused that outrageous value? Was it wrongly imputed? Was it yeah, so based on the reason, you can decide to ignore the outlier if it is carrying too much weight, and like you can't have one value or a few values being so powerful to your model. Like that is very dangerous. So it's better if you remove it and work with just things that are in the normal range. So except that outlier is something that is actually a trend that happens. So say during the Christmas period now, there's usually a spike in the number of sales for items. So if you look at it in comparison to the data for the entire year, where there weren't that many sales, and then in December there's a huge spike, you'd see it as an outlier, but it's actually, yeah, it's an outlier, but it's part of, like, it's actual data, it's real data. You can't just remove something like that, because something like that is most likely to happen the next year again, and the next year and the next year. So depending on if the outlier could just be wrong data, or if it's just data that works with trends, it's just data that gets generated at a specific period of time, then that is what decides if you should let it stay or if you should just take it out. And you letting it stay, you can let it stay, and then to reduce its impact, you can decide to standardize that column. So the values in that column wouldn't be greater than 1 no matter what, and they wouldn't be less than 0. So it's kind of there are different ways to scale the values in the column. So for a standard scalar, that's what happens. It won't go past 1 and it won't go past 0. So you would end up forcing all the values into that bucket, just so that the model doesn't overestimate the importance of that particular outlier. And it kind of balances it out, and it wouldn't impact your models as much as it would if you leave a value of, say, 200 or so in there, and then the rest are all under 5, and then you have one value just sticking out there is 200. So I hope I've answered that question. Well, scaling works really well for outliers that you live in. So there are different kinds of scalars. You'd have to read about them and find out which is best for your use case and which you'll get the most benefits from. Then the last question I'm seeing here is about my experience working remotely as a data scientist. So my experience working remotely as a data scientist, I was trying to compare it to something else, but like I can't compare it to something else, because the only formal office experience I've had was in construction, and working in construction is kind of different. Like, you don't really stay in the office, you move around, you're on site, you're supervising, you're doing a lot of other things. So this is like my first time I'm having to face just work, and that's like I'm working just on my computer, and then I don't have to move around to do other stuff. So I can't compare it to past experience, but what I can say is that working remotely has been ideal for me, because I get to focus a lot more, because I don't have to, I can literally just start working from my bed, like when I wake up in the morning. Like that can literally be the first thing if I want to. And then I have like more control over my time. So because I work remotely, I can decide to, I work remotely, but then I'm required to work the regular hours that those who go to the office are required to work. So I still work an 8 to 5, but because I work remotely, I can be more flexible with this. So if I decide to start working a lot earlier than the rest of the company staff, just because I don't have to navigate through traffic to get to work. So see, I start working by 6 instead of 8. This automatically means that if I'm done for the day by 3, there's literally nothing binding me to continue working, because I have done my hours. And except something comes up and I'm required to, because I'm also required to be available on Slack during the working hours. So if there's a particular case like that, then sure, I have to respond to whatever comes up. But there are upsides and downsides to it, definitely. It would be great being in the same space with your team. Like I've met my coworkers just twice, and we've been working for about 9 months or so now, but I've met with the team just twice. So there's some data scientists in the office. They have a better work relationship than I do because I mostly work on my own, but there are things that the company could do that if you end up working remotely as a data scientist, that will make that aloneness less apparent. So we have calls like weekly. We get to talk about our progress for the week and all of that. So it's not something I really enjoy working remotely. I'm not sure how it would be if I decide to go back to an office to work, because I'm kind of person that gets I lose focus when there are distractions around me. So I work easier when I'm by myself. So that's why remote work has been really good for me, and I'm already very comfortable with my company. So I don't really miss out on not being in a work environment with others, because it's just like this works for me too. So I don't know if are there any other questions?
Yeah, I do have a question. So what are your everyday tools? What are things you do basically, like everyday routine and every tools you use?
Yeah, okay. So everyday routine, it changes with should I say the quarter or with the tasks at hand, but one thing that I use almost every day, or a tool I use almost every day, is SQL. So SQL is something that before I learned SQL, I didn't know about SQL. I didn't know it was important, but at the end of the day, it's the most important or the most frequent thing I have to interface with. So I've gone like 2 or 3 months, let's say 2 months, without writing a line of Python code. Like I had no business writing Python code for those months because I was doing other stuff, but I was writing SQL frequently. So if you do not already know SQL, I would advise you to learn SQL. You can learn SQL from, I'll type a site now. So you can learn SQL from this site, mood.com. So it's a very good site to learn and practice SQL. If you've not learned SQL already, it might be the most important thing you do for yourself as a data scientist, because no one is going to give you, like, you're required to build your data sets yourself. You're required to clean your data and all of that. No one's going to hand you in, like, except for companies where they have data analysts separately who hand you over CSV files to build. But even that is kind of like restrictive. Like, it's better if you get your data set yourself. You can do it better and you'd work faster that way. So I use a lot of SQL, and then I also do a lot of analysis too. Like, there are times that there was a period where I was doing a lot more analysis than science. So I was building dashboards, working with Google's Data Studio. So it's kind of like Tableau, but it's a Google product. And then the model building hasn't, like, when you're learning data science, they would make models seem like the most important part of the job, but that's like it doesn't take time to build a model, like, and building a good model is basically is heavily reliant on the data itself. So how well can you engineer your features? How well can you avoid things like outliers, queuing your data, just basically what can you do to the data to get more from a model. So day in, day out, and then for everything I do it has to be properly documented. So you'd find yourself writing technical reports too. So data science there's a lot of writing, there's a lot of have presentations too, because most times you're working with business people, and business people don't really understand. If you show them your model's performance, they really do not get what that means. Like, you have to translate it into business metrics. So what does this mean for the business? Does this mean I'm losing money? Does this mean I'm getting more customers? Like, with this model, like, how is it going to impact the business? So you have to translate whatever you do to something they can understand. So report writing, is a lot of it too. And then what else? That's like the summary of all the sub things that I do. And depending on the project, it could be a lot of one thing and less of one thing. Like times when I was working with SQL more and very little Python. But for the current thing I'm doing, which is a marketing campaign, to get people to apply for loans, I have to work with Python a lot more. So yeah, it just changes with the quarter. Yeah, and also the company's goals for that quarter also have an impact on what my day or my week or my quarter ends up looking like. So if our target for this month is more disbursements or something like that, I might end up working around tools that will facilitate that. So yeah, it has been very it hasn't been so constant, so to say. Like, there was a time when I was working on an NLP task. I was parsing data sets to understand customers better and all of that. So it changes with the targets and the goals for that period. But SQL, I keep on saying SQL, very important. Learn SQL. Might be the best thing to do for yourself as a data scientist. Any other questions? This has gone on.
What about besides SQL tutorials? What other tutorials do you can point us that help us or books? Whatever kind.
I don't have books to recommend because I am terrible with books. I find it boring to read books. So I mostly do hands-on courses, and then I read a lot of blog posts. And so I mostly consume content in little scattered chunks. That's like how apart from the structured learning I did when I was starting out, but so far it has just been me basically Googling on the job. Like, when I have to figure something out, I literally type how to do this and read up on lots of things and just try stuff out. So, but I'll think through this and think of the best resources I've come across and compile a list and send to Opemi, and she would send it across to you guys. So I'll just think through this and find really helpful materials or posts or sites that I've found that have helped me personally, and then I'll share that across. But this is, guys, I bet you've already read a couple of the articles towards data science. They have good stuff. Yeah. So I followed towards data science, and I read their articles frequently. It's a blog on Medium where data scientists talk about, like they talk about things spanning from technical stuff to their experience at work and all of that good stuff. More questions or? Anyone else?
Can we reach out to you on LinkedIn?
Yeah, sure. You can, name is Markus on LinkedIn. So you can send me, what do you say?
You have your profile. I'm just asking if you can reach out to you personally on LinkedIn in case we need guide.
Okay, you can connect with me on LinkedIn. Like, it would be really helpful if you mention that you're from the Stutern Graduate Accelerator. Yeah, it would be very helpful if you do that when you send a request.
Thank you very much.
Sure. And then another thing I would suggest, even though it's it might not be for everyone, but you can try your hands out at cargo competitions, like just to have that experience. I wouldn't say it's the best thing to do, but it's nice to have like participated in a competition and see, and just like it helps you think about how to apply all what you've been learning. So it's not just about taking courses, but now you get to work on a problem. So cargo competitions have problems defined with data already provided for you. So you can apply what you've learned and then see what you can come up with. So it's a nice way to practice. Because the thing about data science is that if you tell yourself that you keep on learning till you know a lot, or till you learn a substantial amount of stuff, you will never stop learning and you will never start applying what you know, because every other day something new always comes up. So it's best that you start applying knowledge you know as quickly as you can. But I think that's one of the reasons why I was also hired after the internship, because I'd already worked on, I participated in like, I think a competition or two on cargo, and they liked that I'd done something like that. And yeah, it was one of the things that, should I say, made me stand out from some other applicants or some other finalists. So just check out cargo, try out a few competitions. Like, it doesn't have to be an ongoing competition. Good thing about cargo is that people drop their solutions on there. So even if you're not doing it for like to win, you can do it to learn from others too. So you can look at how people have solved problems, learn from that, build on it. Like when you learn from others, always try to add something extra to it. So build on it and not just copy and paste. So there's nothing wrong with copying people's work, just as far as you can add something extra to it. Like that's just what I feel. If you can make it better, if you can make it more efficient, you just learn something new, even though you just followed what someone did previously, but at least you brought your own addition to it. So yeah, try like build stuff, work on challenges as those cargo competitions. other questions?
Thank you very much. Is anyone special with you?
Okay. I think it's just. Can I end the call here, or is there something else that I am required? Just call it a yeah, I think the session is over.
Yes.
So thanks, guys, for having me. I hope someone took at least just one thing from this. Quite bored. I felt that. So yeah. Thanks for having me.
Thank
Bye,
you very
guys.
much.
Thank you very much.
Welcome.
Yeah.
Have a great day. Where do I end this call?
Yeah, and you too.
All right.